This clip will be a brief rundown of the basic concepts related to time manipulation and tempo handling in DAWs. Anyone who's already familiar with features like beat mapping and conforming the tempo of audio files to a different session or project tempo can probably skip ahead. Those who are new to those concepts, or simply haven't had much occasion to use them in their work, might find this background material helpful. So here goes. One side of tempo handling is the ability to change the tempo of a project or session and have already recorded audio files match the speed of the new tempo without any change in pitch or tonal artifacts. Nowadays that capability is pretty well established, but that wasn't always the case. When DAWs were first introduced, they couldn't yet change the playback tempo of recorded audio without unnatural changes in pitch and tone. But people had gotten used to this capability with MIDI recordings. When MIDI was introduced, it marked the first time it was possible to change the playback speed, the tempo, of a recorded musical part without concurrent unwanted alterations of pitch and tone. Audio recordings, however, work differently. When tape was the primary recording medium, changing the tempo of a recording could be done by speeding up or slowing down the playback speed with the tape machine's vari-speed feature. But when audio is sped up or slowed down that way, the pitch is changed and the tone is altered. Normally fixed formants and the envelopes of notes, the attacks and decays, are altered, producing the familiar chipmunk effect. Just like what happens when a turntable speed is changed. The same thing happens if the playback rate of a digital audio file is simply sped up or slowed down. Now, MIDI was always free from this limitation. MIDI tracks are made up of note messages, no actual audio which is triggered from those MIDI notes, so the audio is unaffected by tempo changes. The notes are played faster or slower, but the sounds that are triggered are the same at any tempo. Naturally, people wanted to be able to do the same thing with their audio recordings, but it took quite a while before DAWs eventually devised methods that did make it possible to alter the tempo and playback without creating unnatural tonal artifacts in the audio. At that point, modern time shifting was born. DAW time shifting accomplishes the goal by dividing an audio recording into a series of slices, one slice for each note or syllable, and then lengthening and shortening the duration of each slice to accomplish a faster or slower playback tempo while preserving the pitch and tone of the notes themselves. Simple slices works for percussive sources like drums. For pitched material, additional processing is applied to change the duration of longer sustaining notes or slices, squeezing or stretching them in order to preserve pitch and tone. Different algorithms are optimized for different audio material, rhythmic, polyphonic, or monophonic recordings, and these are sometimes selected manually by the user to ensure that the most effective type of processing is applied to a particular recording. In Logic, this time-shifting feature is called flex time, and it was introduced quite a while back. So a DAW's audio time-shifting capability is used when project tempo changes are made to alter the speed of the audio from its original recorded tempo without creating any unwanted pitch change or tonal artifacts. Any MIDI tracks will always follow tempo changes, but to make an overall tempo change in a project that contains audio recordings, the time-shifting feature, in Logic's case, flex time, must be activated for all audio tracks and the appropriate settings enabled to ensure that the audio will follow any tempo changes and still sound natural. This is how audio is conformed, or matched, to a project tempo other than the tempo at which the audio files were originally recorded. Of course, flexing can also be performed manually for creative purposes too, but here we're only concerned with it as it relates to tempo handling. The other side of tempo handling is doing the opposite. Instead of changing the tempo of the recorded audio, the effective tempo embedded in the recorded performance is used as the preferred tempo, even if it's not consistent throughout the recording, and the project tempo itself is changed. When there are variances in tempo in the recorded performance, a tempo map, a series of slightly changing tempos, is created and used for that project, providing a more natural, more human sense of overall timing. Matching the project tempo to an audio file is done by a process called beat mapping, which consists of moving the bar and beat divisions of the project tempo to match the corresponding locations of those bars and beats in the audio recording itself. This can be done manually or automatically. Either way, the audio is analyzed and transients are detected, which are then used to determine where the project tempo's bar and beat divisions should fall relative to the bar and beat divisions detected in the audio recording. This in turn determines the new project tempo map. Sometimes beat mapping can be accomplished via automated analysis of an audio file. Other times the user may have to manually match project tempo bar and beat divisions to the correct notes and transients in the audio. Every DAW has its own method for doing this. In earlier versions of Logic, there were several approaches. In the next video, I'll wrap up the background material with a brief look at Logic's tempo handling options prior to the introduction of Smart Tempo.